Hi students, this is AJ sir. Let's study 9th standard ICSE Math exercise 14B, rectilinear figures. Also, to enroll for my online test series or online exams or online lectures, email me. Check the description for more information. First, let's acquaint ourselves with quadrilaterals and the various types of quadrilaterals. The A exercise is not in syllabus. A quadrilateral has 4 sides, 4 vertices and 4 angles. That's it, nothing special, nothing else. But remember one property, the sum of all the angles, that is A plus B plus C plus D, is 360. That's right, that's called the angle sum property of quadrilaterals, just like you have an angle sum property of triangles. Now some special kinds of quadrilaterals. First of all, trapezium. It's a quadrilateral, but one pair of sides are parallel and the other pair are not. It's important to note that the one of the pairs is not parallel. That's why it's called trapezium. And if the non-parallel sides are equal, then we say it's an isosceles trapezium, which would mean that the base angles would be equal, or even these two base angles will be equal, just like in an isosceles triangle. Next, we have parallelogram. Here in the quadrilateral, the opposite sides are parallel. Also, the opposite sides are equal. Even the adjacent angles are now equal. And since the sides are parallel, so we can say that the co-interior angles or allied angles or adjacent angles are always supplementary. That is, their sum is always 180. I can even say that this plus this is 180. Also, the diagonals will divide the parallelogram into two congruent triangles. So if you focus on diagonal AC, then triangle ACB is actually congruent to triangle CDA. And now both the diagonals have divided the parallelogram into 4 triangles, and the areas of the 4 triangles are equal. So these are the properties we need to keep in mind. Note that here the diagonals need not be equal in a parallelogram. That is the case only in a rectangle. Now in a rectangle, it is a parallelogram, so it has all the above properties of a parallelogram. Opposite sides parallel, opposite sides equal, 4 equal triangles of equal areas. But it has some additional properties. Each vertex angle is 90 degrees. Here the diagonals are equal. Also the diagonals bisect each other. That means O is the midpoint of each of the diagonals. Next we have a rhombus. Even this is a parallelogram, but here all 4 sides are equal and the diagonals are perpendicular bisectors of each other. When I say perpendicular, means they meet at an angle of 90 degrees with each other. And they are bisectors of each other, means O is the midpoint of the diagonals. But note here the angles, the vertex angles are not 90 degrees. So if you take all the properties of a rhombus as well as a rectangle and combine them into one figure, then you get the most special parallelogram, which is a square. It has all the properties of a rectangle as well as a rhombus. So opposite sides are parallel, opposite sides are equal. In fact, all sides are equal. All vertex angles are at 90 degrees. Diagonals are also equal. Diagonals bisect each other. Diagonals are perpendicular to each other. So all these properties are summarized in this pink table. So make sure you learn this table, which will help you to solve sums. Now, there are many theorems which we are going to use in sums. Some theorems statements have to be just studied. For example, in a parallelogram both the pairs of opposite sides are equal, which is something we know, that is AD is equal to CB, but the theorem here is not there in syllabus. But some theorems are there which you will have to practice for homework, so consider these theorems as a part of your solved examples. Theorem 12, in a parallelogram both the pairs of opposite angles are equal. How are you going to prove that? Well, always write the given, the to prove, and the construction will be just one of the diagonals. Prove these two triangles congruent by ASA test. So by CPCT, angle A becomes equal to angle C. And then you can simply say similarly, angle D is equal to angle B. No need to prove that all over again. So make sure you practice these as well. Next, in theorem 13, the proving is not there, but remember the statement: if one pair of opposite sides of a quadrilateral are equal as well as parallel, it becomes a parallelogram. So any one pair of opposite sides in a given quadrilateral, if we can prove them to be equal as well as parallel, then automatically the other pair of sides will also become equal and parallel, because now this is a parallelogram. Next, theorem 14, each diagonal of a parallelogram bisects the parallelogram. That is, we have to prove that the area of each of the triangles is half the area of a parallelogram. Well, in theorem 12 we had proved that if this is a diagonal, then these two triangles are congruent, and congruent triangles have equal areas, hence proved that each triangle is half of the area of a parallelogram. So practice this. Theorem 15, the diagonals of a parallelogram bisect each other. That means I have to prove O is a midpoint of AC as well as of DB, given that it is a parallelogram. So always write the given and the to prove and the diagram, and if constructions are there, then mention that also. So first we will prove triangle AOB and COD congruent by ASA test, and so then it is obvious that OA is equal to OC and OD is equal to OB, hence proved. Next, in theorem 16, rhombus is a special parallelogram whose diagonals meet at right angles. We have to prove that the point of intersection is at 90 degrees. So here we will prove any pair of adjacent triangles congruent. We know that AO is equal to OC because in a parallelogram diagonals bisect each other. OB is a common side, and AB is equal to BC because sides of a rhombus are always equal. So by SSS test, these two triangles are congruent. That means this angle is equal to this angle by CPCT, but the total is 180 degrees, linear pair. That means x plus x is equal to 180. That means x is equal to 90, hence proved. Make sure you write proper statements while proving each theorem. Now in a rectangle, let's prove the diagonals are equal. Given, to prove. Now prove triangle DAB and triangle CBA congruent by SAS test, and hence the diagonals are equal by CPCT. Make sure you write CPCT. So a lot of congruency properties have been used in these theorems, so it's pretty easy. Now theorem 18, in a square diagonals are equal and meet at right angles. So this proving is exactly the same as that used for theorem 16 for a rhombus. It's exactly same. In fact, it's easier for a square. Solved examples of course have to be done as well. Now let's start with the exercise. Tick sums 2, 5, 4, 8 and 9. So we are going to do 5 sums now. Mark the 5th sum as IMP, although all sums are pretty easy. Now in the second sum, this is the given information. So ABCD is a parallelogram, DM is an angle bisector, so let's assume this is X and X. AM is also an angle bisector given, so let's assume this is Y and Y. Make sure you mention all of that. Now we know that in a parallelogram, the adjacent angles, which are actually co-interior angles, they sum up to 180 degrees. They are supplementary. That means 2x plus 2y is equal to 180. That means x plus y is equal to 90. Now in triangle MDA, if x plus y is 90, then how much is this by angle sum property? 90. Hence proved. Here's the solution. Now the fourth sum. Diagram is not given, so be careful while drawing the diagram. Try to draw it on your own first before looking ahead. Ready? So was the diagram like this? It's a square. That means each of the angles is vertex angles is 90 degrees, and we have to find the values of a few angles as per the question. First of all, we know that diagonals of a square bisect the vertex angles. That means this is 45 degrees, even this will be 45 degrees, this will be 45, and this will be 45 as well. Next, in triangle OBP, it's given in the question that OB is equal to PB. It's given. That means it's an isosceles triangle. So let's assume this is X and X. Angles are equal by isosceles triangle property. So by angle sum property now, I can find the value of X, which comes up to be 67.5 degrees. So I hope you understood till here. You can solve till here before going ahead. Next, Roman number 1, they've asked us to find angle POC. We know that in a square, the diagonals are perpendicular to each other. They're perpendicular bisectors of each other, in fact. That means angle BOC is 90. Out of that, BOP was how much? 67.5. So by subtracting, how much is POC now? Yes, it is 22.5 degrees or 22.5 degrees. Next. Now angle BDC, how much is that? That's 45. So if this is 45 and this is 22.5, isn't this double of this? Well, that's what they've asked us to prove. So this is how we write it. Similarly, in Roman number 3, angle BOP, we had found it to be 67.5 degrees. Check your diagram. It's clearly thrice of angle COP. So even that is proved. Next, fifth sum now. Now here the diagram is given and we have to find a few values. So we have a square as well as an equilateral triangle here. It's an equilateral triangle, that means this is 60 degrees, even this is 60 degrees, and even this is 60 degrees. Also, ABCD is a square, that means DB being the diagonal will bisect the vertex angle. That means angle DBA, that is this angle, is 45 degrees. So angle PBA is 60, but angle DBA is 45, or let me say angle OBA is 45. So OBA is 45 and OAB is 60. So by angle sum property now in triangle OAB, you can find the angle AOB. How much is that? That is 75 degrees. Whatever is in red, that you don't have to draw in your books. So Roman number 1 done. We found angle AOB. Here, solve it first. You should break up the sum. Solve a small part, then go ahead. Next, we have to find angle BPC. Now, if this entire angle was 60, then how much is this, by the way? You know, angle CBA was 90 degrees, angle of a square. So out of that, this is 60. So this will be 30 degrees. Also, triangle PCB is an isosceles triangle because PB is equal to BC. How? Well, PB is equal to BA sides of equilateral triangle, but BA is equal to BC sides of a square. So that way PB is equal to BC. But you can directly write it because in the diagram I've already shown that they are equal. So it's fine. So this is an isosceles triangle. So let's say this angle is equal to this angle is equal to x each. Oh, have I used x already? No, I haven't. So that was in the previous sum. So here I can use x. If in the same sum I have already used x, then you can't repeat it. You'll have to use some other variable like y. But here I will use x. So by angle sum property, I get the value of x, and well, incidentally, even that is 75 degrees. So Roman number 2 done. That's how to solve it. These are the steps. All the steps, all the reasonings, all the names of the triangle which you are considering for each step, or the name of the square or the name of the quadrilateral has to be mentioned. They carry marks. Next, they want us to find angle PCD. Now, angle BCD is totally 90 degrees, angle of a square, out of which this angle PCB is 75 degrees. We just proved it. So how much is left for this small angle PCD? Yes, it's 15 degrees. So that's your solution here. And now Roman number 4, they want us to find a reflex angle APC. What's a reflex angle? See, if I say angle APC, then you will show me this one, this angle APC, which is an obtuse angle. But a reflex angle is an angle which is greater than 180 degrees, which would be this one. So it's quite the opposite of angle APC. Now, if you notice, angle APC and the reflex angle APC totally sum up to be 360 degrees. That's the property we will use to find reflex angles. First, we will find the value of angle APC, and then we will find the reflex angle, which will be 360 minus this value. But how do I find this? Well, this angle APB is actually 60, angle of a equilateral triangle, and x, well, we've already found that to be 75. So it seems angle APC is 135 degrees. So reflex angle APC, the remaining angle, will be 360 minus 135 degrees, which comes up to be 225 degrees. And with that, this sum is over. Next, in the 8th sum, in a quadrilateral, they have given a ratio of the angles. So this is the diagram I'll draw. Of course, whatever is in red, you never should write. This is just for explanation purposes. So here the given is not given in the question. So we'll have to write the given and the to prove before starting with the proof. So whenever ratios are given, what strikes you? Your mind? Well, we'll take the constant of proportionality as x. So we'll say, let this angle be 3x, 4x, 5x and 6x. Also, we know that angle sum property of a quadrilateral, yeah, this is the symbol of quadrilateral, is 360. So when I add all the angles, I can get the value of x as 20. I can substitute and get the values of all the angles. So I get this as 60, I get this as 120, this is 100, this is 80. Now notice that the allied angles or the adjacent angles are supplementary here. It's 180. This proves that this is parallel to this. See, if it was given that DC is parallel to AB, then we know that angle D plus angle A will be 180 by co-interior angles property. But here we are doing the reverse. Here we are proving that the sum of the co-interior angles is 180. Hence it is proved that DC is equal to AB. But hold on, that's not enough to prove it to be a trapezium. What about AD and CB? Are they also parallel? Let's find out. don't be misled by the diagram. I knew the answer, so I drew it like that. But how would you know whether it's indeed a trapezium or not? Well, add them. This and this, these two angles are also adjacent, or you can use these two angles also. So these two angles are adjacent angles. They are also called co-interior angles, yes, but they are not supplementary because these sides are not parallel. So after having proved one pair of sides as parallel and the other pair of sides as not parallel, only then we can conclude that the given quadrilateral was a trapezium. Understand that it was not a parallelogram given to us, it was a quadrilateral given to us. Now in the ninth sum, again they have given some information. We have to draw the diagram. They said that in this parallelogram, yes, it's a parallelogram, AE is an angle bisector. So this angle is equal to this angle, and it meets BC extended at F. We have to find the value of CF. So first of all, it's given that this angle is equal to this angle. It's given. And since AD is parallel to BF, that means this angle is also equal to this angle by alternate angles test. And also always mention the parallel lines when you mentioning this. So if this angle is equal to this angle, but this angle is also equal to this angle, that means this angle is equal to this angle, and that makes triangle AFB an isosceles triangle. That means BA is equal to BF, isosceles triangle property. If BA is 20, then BF is also 20. If BF is 20 and out of that BC is 12, then how much is CF? How much is it? 20 minus 12, 8 centimeters. So have a look at the solution.